Hello guys, welcome to this video lecture series on pointers in C. In this video, I am going to talk about pointers and arrays. Pointers and arrays are closely related concepts in C, but remember, they are not the same. In this video, I am going to demystify about the pointers and arrays, and specifically I am going to talk about 1D array or one-dimensional array. To understand arrays and pointers in details, let us first create an array named A with 5 elements 1, 2, 3, 4 and 5. Now whenever I declare an array A with 5 elements, inside computer's memory this array A would look something like this. If you observe closely, the elements in this array are sequentially arranged, that is, they come one after another, and each element in the array is going to have an address, and I am assuming that the base address is 1000 for this array. Also, let us assume that the size of int be 4 bytes. If size of int is 4 bytes and the base address is 1000, the second element would have the address 1004, the next one is 1008, 1012 and 1016. Index in array starts from 0, so first element is accessed by writing A0 subscript 0. Similarly, ith element is accessed by writing A subscript I. This will give me the ith element of the array. A0 gives me 1, A1 gives me 2, A2 is 3, similarly A3 is 4 and A4 is 5. Now let me throw a very important question to you all. If I print A, what happens? If you do this, A will actually print the base address of the array. So A prints 1000. Now if A prints 1000, A must be a pointer. Actually, A is a pointer. Therefore, A prints 1000. So if A is 1000, if I perform A plus 1, I'll get the next address, the address of the next element in this array. Similarly, so A plus 1 will give me 1004, A plus 2 is 1008, A plus 3 is 1012 and A plus 4 is 1016. The first element is having the address A, or this can also be written as A plus 0. Now if A plus 0 will give me the address of the first element, to get the value that is 1, using pointer notation I can write asterisk A plus 0 is equivalent to A0, which is equivalent to 1. Asterisk A plus 1, this is asterisk A plus 2, asterisk A plus 3 and asterisk A plus 4. So in generic, if I write array using subscript notation like this AI, and I write %AI, the equivalent pointer notation would be %AI can be written as A plus I, and AI can be written as asterisk A plus I. Both are the same thing. Let us now declare a pointer to an integer. So let that pointer name be PA, and let this pointer have the address of the first element of this array, that is address of the first element, that is %A0. So what does this statement do is that it will create me a box which is named as PA, and this box is having the address of the first element, which is 1000. So I can say that PA is pointing to this array A. Now what is PA plus 0, or what is PA? PA is nothing but 1000. So PA and A plus 0 are equivalent. So I can write A plus 0 as PA plus 0, because PA plus 0 is also 1000, A plus 0 is 1000. What is PA plus 1? PA plus 1 is equivalent to A plus 1, which is 1004. So this is PA plus 2, PA plus 3, and the last one is PA plus 4. Similarly, the next element can be written as PA plus 1. This is asterisk PA plus 2. Then the element at index 3 is asterisk PA plus 3. And the last one is asterisk PA plus 4. So in this, what you observe is PA and A both are having the address 1000. So can we say that in this case PA is a pointer and A is an array? Can we say that they are all the same? The answer is no, because PA is a pointer and A is an array. But if you can recall, I've told you that A is also a pointer. Yes, A is a pointer, but this is a constant pointer, a pointer which is constant or cannot be changed. So the fundamental difference between the pointer to an array and array is that both are actually pointers, but array name or array is a pointer constant, whereas pointer variable is a variable. So I can perform any sort of increment operators on pointers. I can do PA plus plus, I can do PA is equals to PA minus 1. I can do all these operations on pointer variable. But remember, I cannot do A plus plus. This is not allowed. I cannot do A equals to A minus 1. This is not allowed. Because if I am being allowed to modify the base address of an array, that array would not exist in the memory then. Therefore, I am not permitted to perform any increment or any decrement or any changes to the array. So that is an invalid operator. I can do A plus plus or A equals to A minus 1. Therefore, array is a pointer which is constant. Once it is fixed, I can't change it. But PA is just a pointer. It is having the address of an integer variable in this case, or in this case it is having the base address of this array, which is nothing but the address of the first integer value. There's one more difference. Whenever I declare A, it actually reserves, in this example it reserved 5 bytes for 5 integer locations for me. But whenever I declared a pointer, it actually just it just created one box for me which can actually hold the address of some other integer variable. So that's the difference. So therefore, pointers and arrays are related, but they are not the same. I hope this concept is clear through this video. Now let us demonstrate our understanding of pointers and arrays. In this program, A is an array with 5 elements as shown here. PA is a pointer which is pointing to my array A. Now let us see what does A print. So first we'll see what A prints, and then we are trying to print the address of A by using 3 different ways. First, using ampersand, that is ampersand A0 should give the address of first element at index 0. Similarly, A plus 0 should give the same address, and PA plus 0 also should give me the same address. So in a nutshell, you can say that ampersand A plus I and PA plus I are equivalent. All of these expressions will give you the address. Now AI asterisk A plus I asterisk PA plus I should be equivalent. That means AI should give me the element at index I, asterisk A plus I should also give me the element available at index I, and asterisk PA plus I should give me the the value that PA plus IP is pointing to, that is also the element at index I in the array A. So let us now try to run this program in our terminal. So I already compiled this program. If you compile this program on your own, you may get warnings, because if you observe here, I am printing the addresses. So all of these are addresses. I'm using %d format specifier, which is actually wrong. So to avoid warning, you can use %p instead of %d, but still it will work. Okay, so let me try to run this program. Now if you look at this, what does A print? So A is the base address, which is nothing but 129744320. This is the base address of my array A. So if I print %A0, %A0 and A are equivalent, so both are the base addresses of A. They are the same thing. Similarly, A plus 0 and PA plus 0. If you observe, if you look at all of these two lines, the address is 129744320, which is the base address of A. Now, %A1 is the address of the first element, that is the element at index 1. So this is nothing but 129744324. The previous one was 320 and this one is 324. The difference is 4. This means the integer occupies 4 bytes in my system. Similarly, if you look at A0 or asterisk A plus 0 or asterisk PA plus 0, that all of these will give you the value. So asterisk A0, A plus 0 or A0 or asterisk PA plus 0 will give me the value that is stored at this address 129744320. So it will give me the value 1, which was the first element, this one 1. Similarly, if I write A4, it will give me the value 5. Alright, now before leaving or before ending this video, I'd like to give you a very interesting problem which I want all of you to solve and comment in this video. So what happens if I print something like this? %d, if I print 3a. So my question is it valid? If it is yes, then what's the value and why it is valid, or why is that value, or why it is not valid? So can you comment your answer in this video? Thanks for watching.